Solving non-factorable quadratics, Algebra 2 Common Core. Just including a note in this video that the classwork following this video tomorrow will be in your workbook, so please remember to bring your workbook to class. Once again, please remember to bring your workbook to class tomorrow. So, solving quadratics that can't be factored. We're coming off of a chapter that had a heavy amount of factoring in it. And that's how we were solving things like this. But sometimes we get quadratics like this, where x squared minus 6x plus 2 is simply not factorable. I mean, this would be a very basic trinomial. You could try grouping and things like that, but there's nothing that multiplies to 2 and adds to negative 6. So it simply is not factorable. And that can mean several things. First of all, it definitely means we don't have rational, or at least two rational roots. It could mean that we have irrational roots. It could mean we have imaginary roots. And we're going to learn more about what I mean by rational roots, imaginary roots, and things like that down the line. But for now, it's how do I solve this? And you've learned this before. So this whole video is another one of those review videos from Algebra 1. And the two ways that you learn in Algebra 1 were with the quadratic formula, which is always given to you. Students back when I was in school, we had to memorize this. This is given to you now on your Common Core State Regents reference sheet, so you don't have to memorize that anymore. So I'll give it to you in class and on a test. And then the process of completing the square. They both are going to get us the same thing. Completing the square is a very useful tool that we'll use in other things throughout the year, but it can definitely be used for this. So we have a formula and a process, and that's really how you want to kind of look at these. There's a formula and then there's a process. So let me show you them both and see how we end up with the same answer, and this is what we'll practice more in class tomorrow. So first of all, a quadratic has three pieces to it, an A, B, C, and A, B, and C are represented by the numbers. So the number in front of x squared is A, in this case a 1. The B, which my B's look like 6, sorry, but in this case it's negative 6. And the C is represented by 2. A common mistake is people think that like A is 1x squared. And sometimes we do kind of call it the A term, but when we talk about A for the quadratic formula, we're really just talking about numbers. Everything that goes in the quadratic formula here are all numbers only. No variables get plugged in there. The only variable here is x, and that stays over on the left side. So you're never going to plug like an x or a y or anything in here, just numbers. So it's simply substitution. Negative b, if b is negative 6, negative b is positive 6. So you can think of this as kind of like the opposite sign of b, opposite sign b. Negative b doesn't mean that it's negative. It just means that it's the opposite sign of what b is. If like I multiply negative 6 by negative 1, I get positive 6. So it's just going to be 6, negative b. Plus or minus b squared is negative 6 squared. And I think it's important that you put that in parentheses. And if you're planning on using your calculator for a lot of this, simplifying the numbers here, that's fine. But if you don't have negative 6 in parentheses before you square it, your calculator is going to tell you it's negative 36, and that simply is not true. Negative 6 times negative 6 is positive 36. So you need to have parentheses there, especially when you're squaring a negative, because you need to remind yourself that that's going to come out to be positive. Minus 4 times A, which we have is 1, times C, we have is 2. And that whole thing down here, this whole piece in here, everything in this is called the discriminant. And the discriminant is useful, and we'll probably talk about that again another day, but the discriminant is very useful because it tells you about the roots. I don't want to go too much into that right now, but basically, because it's in a square root, if this comes out to be positive, then that means it's real. If it comes out to be negative, it's imaginary. And we didn't really talk about imaginaries yet too much, but the square root of a negative is an imaginary. If this comes out to be a square, that means it's rational. If it comes out to be something that's not square, like 7, the square root of 7 is irrational. And if the whole thing comes out to be 0, then that means we really only have one root. And that has to do with the plus or minus, because 6 plus 0, 6 minus 0, you end up with the same thing. And that would mean one root with a multiplicity of 2. And we're going to learn about multiplicity in the next lesson. So the discriminant kind of tells you a lot of things about the roots without telling you what they are specifically, numerically. But we'll talk more about that another time. So we do want to simplify that whole thing, but all of this is over 2 times A, and that's going to be simply 2 times 1, which In this case, it's just going to be 2. So we'll simplify a few things here. 6 plus or minus, and then the discriminant up here, this comes out to be, let's see, negative 6 squared is 36. And then now this minus 4, you kind of have to realize that that is negative 4 times 1 times 2. And negative 4 times 1 is negative 4, times 2 is negative 8. So I end up with 36 minus 8 over the whole thing. 2 times 1 is 2. X equals 6 plus or minus the square root of 36 minus 8 is 28 divided by 2. Now, students are usually pretty good up to this point because you could type that whole discriminant in your calculator and get 28. And the other parts are pretty simple. So that's not too bad for most students, but this is where they tend to mess up, simplifying from here. I can't divide these things by 2. And you're like, yes, 6 and 28 can divide it by 2, but because this is a radical, it doesn't work that way. You always need to simplify the radical first before division. So I may end up dividing everything by 2, but I need to reduce or simplify rad 28 first. And again, now there's times where that can't be simplified. There's times where it's imaginary, but we'll get to the imaginary another day. So let's see here. It's going to be 6 plus or minus. The things that multiply to 28 are 4 times 7. One of them has to be a square. 4 is the square, and a square root of 4 is 2, so that comes out, and the rad 7 stays in. Again, this is not a video on how to simplify radicals. You're expected to know how to do that already. Now that this simplified the radical, now I could think about division. And when you're dividing these, it has to be all or nothing. Sometimes we like to draw a very pretty heart around it, meaning that everything in here has to be divisible by the same thing. Like if this was 6 plus or minus 5 over 2, then you can't simplify any of it. You can't simplify the 6 and the 2, only those, unless you want to split it up into 2 fractions, but we're not going to do that. But it's got to be all those, not this, the numbers outside of it. And they can all be divided by 2. So 6 divided by 2 is 3, plus or minus 2 divided by 2 is 1, which I'm not going to write because it's times rad 7, and 2 divided by 2 is 1. So divide by 2 was 3, divide by 2 was 1, divided by 2 was 1, and this is my final answer. All right, so that's a quadratic formula, and you should be familiar with that. Now, how do we do completing the square? So completing the square is not a formula, it is a process. 6x squared minus x squared minus 6x plus 2 equals 0. The first step in completing the square is that is the only thing that's not set equal to 0. You set it equal to the constant. And in this case, that's this 2 over here. So I need to minus 2 on both sides to change this to be x squared minus 6x equals negative 2. That's the first step. Secondly, there can't be a number in front of x squared other than the 1 that we don't write. But if there's like a 5 here or a 2 or a 3, it must be divided out or factored out. And that's a more complicated version of completing the square, which I'll show you in class. This is just the basics. So there's a 1 there, so we don't need to worry about it yet. But when you do see a number there, we're going to have to take a couple extra steps, which I'll tell you later. But we add something to both sides here. So we make this plus something equals negative 2 plus something. And that something comes from a little mini formula of negative b divided by 2, or not negative b, it doesn't have to be, I'm sorry, it doesn't really matter. But it's b divided by 2 squared. And so the b term, as I mentioned earlier, is negative 6. Divide that by 2, you get negative 3. I'll write this over here. Negative 6 divided by 2 squared ends up being negative 3 squared, and anything squared is positive ends up being 9. And so that's what you add to both sides, is 9. Half of b squared. But that's why it's always plus, because it comes from something squared. So half of b squared gets us the 9 there. And that's the step that most students forget, is how to get that number. So remember, b divided by 2 squared. So there's a little formula piece attached to this process. Then you factor the left. And this is basic trinomial factoring. What multiplies to this adds to this. And it's always going to work out to be the same binomial twice. And I'm going to simplify this over here to just be 7. And that's intentional because that makes it a square binomial, and I can write it as x minus 3 squared. That's why it's called completing the square. And the shortcut here is that b divided by 2 is what you end up in here. So some students kind of don't even think about it as factoring. They could jump right to this by thinking, all right, just half of this goes in there. But it does come from factoring if that's helpful. Then we square root both sides. And I square root this and I square root this. Now when I square root something being squared, they kind of undo each other, and I'm just left with what was inside, x minus 3. When I square root both sides, I have to introduce to the right the plus or minus symbol, and I get the square root of 7. So plus or minus the square root of 7. Lastly, I need to move this 3 over because I want to be x equals, and so I'm going to add 3 to both sides. And when you add or subtract something, it goes in front of the plus or minus, not behind it, not in here, completely in front of it. So a positive 3 got moved over, plus or minus, add 7, and you see that it is the same answer I got from the quadratic formula. You do need to examine this to see if it could be simplified. In this case, it can't, but that's how we do these two methods. So we're going to practice this in class. Again, these are things you should already know and already be skilled in, but they're valuable skills in Algebra 2 and going forward in pre-calc and calc and so on. So that's why we kind of do them and remind you about them every year. So quadratic formula, it's just a plug and play, but be careful with all the algebra. And the completing the square process, set it equal to the constant, b over 2 squared, factor, square root, simplify, done. There's going to be times where you have an option. There are times where one might be easier than the other, but we'll take a look at this in class. All right, that's it.